Newton's third law states that all forces between two objects exist in equal magnitude and opposite direction. So using this principle, when the compressed air accelerates the water out the nozzle, an equal and opposite force is applied, causing the rocket to accelerate vertically upwards. When it comes to propulsion, impulse is a product of the thrust of the water rocket and the time the thrust is applied.
By using the wind tunnel simulation in Unity, we were able to establish a relationship between the stability of the rocket and where the fins are placed. We found that the lower the fins are placed on the rocket, the more directionally stable it is. Directional stability is the stability of the rocket perpendicular to the direction of travel. Theoretically, the best fin shape for a rocket is an elliptical fin shape, as it produces the least amount of drag.
The terminal velocity occurs when a falling object reaches a constant speed due to the gravitational pull and the drag force being equal, as this means acceleration is equal to zero. An increase in the parachute's diameter will result in a decrease in the terminal velocity of the rocket. If we plot flight time against diameter, we can see that a larger diameter will lead to a longer flight time. However, the rocket will also drift further, and may run the risk of not landing within the 50 by 50 landing square, especially if there's adverse weather conditions.
A larger parachute allows for a longer flight time, as large parachute diameter decreases the speed of descent at the cost of weight and deployment capabilities. With a big parachute, the simulation achieved a flight time of 18.1 seconds. On the other hand, a rocket with a small parachute descends much quicker, with a total flight time of 7.42 seconds. A rocket with a low build quality, which is more representative of what we will have built as students, has a shorter flight time due to the delayed parachute deployment. The parachute could, for example, deploy during descent, which causes a large loss of flight time. A rocket with a high build quality will have a smooth deployment of the parachute at the apogee, which is ideal for an increased flight time. In low wind speeds, one can observe a small deviation of the aircraft, whereas in high wind conditions, the deviation of the aircraft becomes more important, causing the rocket to exit the 50 meter by 50 meter area. In order to maximize flight time, it is therefore important to have a large enough parachute whilst minimizing the deviation of the aircraft due to wind.